Hello, ladies and gentlemen. Today we will be doing Pre-Calc Lesson 74, and we will be talking about Cramer's rule. Now, Cramer's rule comes from linear algebra. Linear algebra is the study of patterns of coefficients in systems of linear equations. Okay, now there was a famous mathematician who studied linear algebra, and he did lots of really cool things in it that we won't get into now. You can wait and take math history if you so choose. But his last name was Cramer, and he came up with Cramer's rule, which concerns patterns of coefficients in the solution. So we are going to derive, which means solve for Cramer's rule. Okay. I'm going to have ax plus by equals e, cx plus dy equals f, and we are going to solve by elimination. Okay, so the first thing that I'm going to do is I'm going to multiply this top equation by d and this bottom equation by negative b. So on top I will have a dx plus b dy equals ed, and on bottom I'll have minus bcx minus b dy equals minus bf. If I add these together, this term cancels, leaving me with AD minus BCX equals ED minus BF. And to solve for x, I'm going to divide both sides by AD minus BC, leaving me with x equals ED minus BF over AD minus BC. Okay? I'm going to do the same thing to solve for y. Okay, my original equations, I have ax plus by equals e and cx plus dy equals f. Except I'm going to multiply this top equation by minus c and the bottom equation by a, leaving me with minus acx minus bcy equals minus ec, and acx plus ady equals af. If I add these together, this term eliminates, leaving me with ad minus bcy equals af minus ec. I divide both sides, because we parent evenly, by ad minus bc, leaving me with y is AF minus EC over AD minus BC. Notice they have the same denominator. Okay. Now, the numerators are different, which is okay. And I can actually find that each of these numerators is a determinant. We remember how to find determinants of a particular matrix. So if I look at x, if I was to rewrite this ed minus bf, the determinant, in a matrix, I would get the matrix E, F, B, D. And if I did the same thing for the denominator, I would get the matrix A, B, C, D. Which again, if I did the determinants of each of these, I would get ED minus BF over AD minus BC. I can do the same thing for Y. I will get A, E, C, F for my determinant on top, and my determinant on bottom, or my matrix on bottom, is the same. Okay, I'm going to rewrite our original two equations. AX plus BY equals E. CX plus DY equals F. Okay, notice from here, okay, the bottom matrix, or what we call the coefficient matrix, is just that. It's the coefficients. We have the coefficients of x in our first column, and we have the coefficients of y in our second column. See, we have A and C corresponds to A and C here. B and D corresponds to B and D here. Our top matrix, the x coefficients become constants when solving for x, and the y coefficients become constants when solving for y. What does that mean? If we look at x, okay, notice that my first column is the answers, okay? The second column is the coefficients of y. If I look at solving for y, the second column is my answers, and the first column is the coefficients of x. They are meant to mirror each other. Okay? Now I know all of this is a lot, so let's do an example to make more sense. Okay? So example 1, we are going to use Cramer's rule to solve. Okay? We have 3x plus 2y equals -1, and 4x minus 3y equals 10. Okay, I know I'm going to solve for x and for y, and I'm going to create fractions. My denominator is the coefficient matrix, right? I have 3, 4, 3, 4, 2, -3, 2, -3, and that's the same for both. Okay? Now, for the top, remember for x, we start with the answers, and then we use the y coefficients. For y, we end with the answers, and we start with the x coefficients. Okay? Now, if we remember in matrices, these straight lines as borders tells us to take the determinant. Let's do a little side note. The determinant is AD minus BC. Okay, so here we will have 3 minus 20 over -9 minus 8. And here we will have 30 plus 4 over -9 minus 8. Look, notice this was a minus -4. That's how it created a plus. So, bringing it down here, I will have -17 over -15. -17, which gives me 1. And I will have 34 over -17, which gives me -2. So my solution, we always write as an ordered pair, is x comma y, or 1, -2. Okay? Let's do another example. We're going to use Cramer's rule to solve 5x minus 3y equals 1 and 2x minus 7y is negative 17. This is a really nice way to solve things because it's much faster than using substitution or elimination. Let's write our coefficient matrices. We have 5, 2, negative 3, negative 7. And then for x, we have 1, negative 17, negative 3, negative 7. For y, we have 1, negative 17, and 5, 2. The order matters, so pay attention to your order. Okay, so on top here we will have negative 7 minus 51 over negative 35 plus 6. And here we will have negative 85 minus 2 over negative 35 plus 6. This gives me that x will equal 2 and y equals 3, which we always write as an ordered pair, always, 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 and forever, 2, 3. Okay? Let's do another example. We're going to use Cramer's rule to solve 6x plus 4y equals 10 and 3x plus 2y equals 8. If you feel like you understand Cramer's rule, then pause the video right now. Try the problem yourself. See if you can do it without me, and then play it to check your answer. So we use our coefficient matrix, which is 6, 3, 4, 2, and it is the same on both sides. Now for x, my coefficient on top is 10, 8, 4, 2, and for y I will have 6, 3, 10, 8. So x, I get 20 minus 32 over 12 minus 12, bum, bum, bum. And for y, I'll have 48 minus 30 over 12 minus 12. Bum, 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 bum. Why is this a big deal? Because we will have negative 12 over 0. Eek! We cannot divide by 0. OMG. That means there is no unique solution. Okay? This is a special case that we will see. Okay? We find that these lines are parallel, meaning they never cross, so they never have a solution. In our last example here, the solution we get, this is where the two lines intersect. That is what a solution to two lines is, a system of two equations. It's where they intersect. So here, there's no solution, so they don't intersect. They are parallel. Okay? Now, this is always true if we have a determinant that is 0. So let's talk about special cases. When the determinant of coefficients of a system of linear equations has a value of 0, the system does not have a unique solution. Which means there's no solution if they are parallel lines, and there's infinite solutions if they are the same line. Okay, meaning that if we have a 0 anywhere as a determinant, then there is no solution. Be careful of your special cases. This does not just equal 0. It's undefined. Okay? Again, if you have any questions, you need to bring them to class tomorrow. That is all we have for today.